So we just studied the electromagnetic spectrums. So this is definitely a distribution of the different kind of wavelengths of the EM wave. Yeah. So now let's try to study about the atomic spectrums. So this is definitely something we have not yet learned. We will cover that with more details when we study the chapter 30 about the quantum physics and the atomic structures. Then you will have a clear idea what do we mean. But I think some of you may have already learned this part of the concept in the chemistry already. So let me briefly just describe what happens without explaining too much about the physics. So here you can see that there are different kind of the low pressure gas made of different kind of the atoms. It is made of hydrogens, heliums, neons, and mercury. So they are within the low pressure one, and then you impulse the pressure, the gas with an electric field. So the electric field would provide them the energy to the electrons orbiting around the nucleus. And they find out that because depending on the electric field impulsed, also depend on what kind of gas you use, they will produce a series of the lines, and these lines are separate from each other. It is not continuous. It is discrete symmetry. So this is the so-called line spectrums. And this line spectrum for each of the atoms is different. They all have their own unique the line spectrums. And the simple explanation for this is that, so we all know that all the atoms made of the numbers of the protons and neutrons at the center as a nucleus, and a bunch of the electrons orbiting around. This is all you need to know right now. So the electric field will excite the electrons orbiting around the nucleus so they can jump. But based on the rule of the quantum physics, they can simply jump arbitrarily to any the orbit that they want. The energy given should be specific. So for example, if they need 1 joules, then it is 1 joule. If you give them 1.1, even bigger than 1, it still doesn't work. You should have exactly the correct value. The electron will jump. And each atoms have different kind of structure of the orbit. So the energy required for the electron to jump is different. So that's the reason that each of the atoms, when they jump in between the orbits, the energy required is different, which means the energy emitted out as a light, as a spectrum, is different. And this is the so-called atomic spectrums. And that's the reason you can see that when they jump, they will emit the light, and they are in a different color. So what does it mean? At different kind of frequency of light. So let's focus on the last one, the mercury, as examples. How does this happen? So actually, when you go to the downtown, people use this kind of the fluorescent tube frequently, produce a light. And they can, based on the gas within that, they can choose what kind of color they want to produce. So what is the fluorescent tube? First, it is a tube filled with the low pressure gas. And today we are going to focus on the mercury because it is a very good choice for that. And now what you are going to do is that once you create a low pressure gas mercury, then you are going to connect it to an electric field. So what does it mean? There is a electric potential difference. And let's assume this is a positive one and this is a negative one. So the current will flow out. So current will flow out from the electric field and interacting with the mercury atoms. But what is the current flow? Actually, it is the movement of the positive charge. Yeah? So it is the interactions of the high energy electrons with the neutral mercury atoms. So this kind of the electrons will excite the vapors. So which you mean now the electrons originally within the mercury atoms, they will be excited. Then they will emit the UV rate. But this is not the frequency you can see. So this UV light is the frequency beyond our eyes range. So we have to provide another coating, the phosphor, on the inside layer of the lamp. So when the UV light interact with the coating, they will produce a light and add a visible light, which is the blue light you can see here. So this is why you can see the blue light here. So now in the chapter 30, what you're going to study, how to understand this kind of light production through the movement interaction of the electrons. So have you seen that in the chapter 14, we studied the very general concept of the wave. And in the chapter 25, we study what is the EM wave. So EM wave is just one of the example of the wave. Then in the chapter 26, we focus on one particular kind of the EM wave, which is the visible light. But intrinsically, they are still the EM wave. And now we find out that the concept, the EM wave, and the concept of the geometric light property there can be understood a lot when you study the subatomic structures of the atoms. So that's the reason why we are going to study later at the end of the semester about the quantum physics and the atomic structures. So now we are going to go back to study about the concept of color, because now you can see the color, it depends on the frequency of the light. So let me claim and make this kind of the strong statement here. The color actually is an illusion. If you understand the physics, it is the illusions. So here I say the colors depend on the light source. So have you had this kind of experience? Not just having the makeup, or even wearing the clothes, wearing the clothes and trying in the dressing room. You will see a color more close to a black, or here when you have the lips with the color of the pink in the indoors. But this is a light source you use when you are in the bathroom. But you will find out when you go out with the sun as your light source, your clothes doesn't look like that perfect black. It is more close to the navy blue. And here, in the example here, the color is no longer pink anymore. It looks more red. Why this? Why? Which color is the true color? And why this happens? So here the argument is that the color actually depends on the light source. And then we are going to spend a lot of time on that. But before that, I'm going to give you a challenge, the conceptual quiz, even though I did not explain a lot of physics yet. So you will have the red rose. But now, under what kind of scenario, it will not look like red. So you have provided 4 different kinds of light source here, yeah? So the answer is D, the sign light. So if you shine that with a red light, it will look like red. If you shine with a white light, it will definitely. Because you know white light is made of the spectrums of the light, yeah? And orange, you can see that they are more close to the red light. The frequency is more close. But cyan is the frequency which is much bigger than the red light. So they cannot compensate each other. So if you try to shine your rose with the red light, with the cyan light, the color will no longer be the same. But why? I did not explain to you. Yeah? But this is the experiment you can try to conduct if you could in the daily life. And here is the explanation. It is due to the selective reflections. The reason is that a lot of objects in our daily life, they don't emit the light. So they are not the light source itself, agree? But what they are doing is they reflect light. So the color on your lips actually is the examples. Or the color of your clothes is also the example. So this kind of material can absorb some light, but not all of them. It depends on what kind of material it is made of. Apparently, the clothes is made of different kind of material element than your lips. Yeah? So for this kind of material, it depends on what kind of light will be absorbed and what kind of light will be reflected. So for example, here you have a tomato. So why the tomato looks red? So the light source is the sun. So the sun will shine a white light on the surface of the tomato. But the tomato, why the skin looks red, is because only the red light is reflected. The green and the blue light was absorbed. So it looks like red one. So for the lemons, similar things. You shine the white source on that, but the green and red light will be reflected. So there are two different kinds of light will be reflected. And it is this combination of the two lights make the skin of the lemons look yellowish. So you see, two different kinds of light was reflected, green and red. But now it looks yellow. I will give you a very clear explanation why in physics. So the most important information in this slide is that the color of an object which does not produce the light, the color actually could be arbitrary. It depends on what kind of coating on the surface. So when I say coating, means that they can reflect a different kind of the frequency of the light. So it could look like black, red, or green. But the point is that it is not a true color. Or you can say you don't even know what is the true color of the object. The color is illusion. Okay? So now, before I give you to the next slide, did you see that I try to imply that the light from the sun as a white light is intrinsically made of three main elements, the green, red, and the cyan light. So these three are the most fundamental elements try to compose of the white light. So this is a concept of an additive combination of the colors. So if you have a red light source, cyan light source, cyan light source, and the green light source. So when you combine the three together, they will become the white light. So did you see that? Now that is the reason why here, if you have a white light, they will be spread out, but you can naively separate them in terms of the red, green, and the cyan. So this is the so-called fundamental three elements to making the white light, the color. So this is a primary color. And you can see this is second common one. And when I was a kid, actually, I feel a little bit confused. So let me say my understanding of this. This is for the light itself. So if you have a light source produce the red, green, and the cyan, but the secondary color here is for the painting. They are not the light. They are the coating itself. So you will find out that if you try to combine yellow and the cyan, it will become greenish. So you can see the combination is different. So when we say primary, this is for the light. And when they say secondary combination here, it is for the painting coating. So the cyan, the magenta, and the yellow are the one. So I know that I a little bit arbitrary when I try to say about the blue and the cyan. So now in the future, I will be very precise. For blue is for the light, and the cyan is for the painting. In the future, I will make it precise. So now let's try to take a look about how this applies to the example we just have. So here I just say that if you have the reflected light, which is green and the red, but eventually the color of the skin looks like yellowish. Why? You see, the intersection of the red light source and the green light source, the intersection is yellow. So that's the reason the skin of the lemon looks kind of yellowish.